we started with lesson 10, heat, and explained what is heat. I had explained to you all what is heat and then what is heat energy and what is propagation of heat. That is your movement of heat from one body to another. Okay, movement of heat from one body to another, one object to another. Can I have your video on, please? Anna, Emma, and Abraham. Can I have your videos on, please, real quick?
Yes, ma'am.
Okay. So we saw what are the effects of heat. The change in size, rise in temperature, state, change in physical, chemical properties, and damage to living cells. Then we saw how temperature is measured. We saw clinical thermometer and laboratory thermometer. Now, we saw the modes of transfer of heat. Okay, this is an important question that you have to cover. Modes of transfer of heat. Okay, we saw radiation. We saw convection. We saw radiation and convection and conduction. Three things we saw. Okay, through which the heat can be transferred from one body to another. Okay, now next we have land breeze and sea breeze. Videos on, please. Please turn on your videos. Next we have land breeze and sea breeze. The people living in coastal areas experience an interesting phenomenon. During the day, the land gets heated faster than the water. The air over the land becomes hotter and rises up. The cooler air from the sea rushes towards the land to take its place. The air from the sea is called sea breeze. Okay. At night, the land cools down more quickly than the seawater, so the cool air from the land moves towards the sea. This is called land breeze. Okay, what happens in land breeze, sea breeze? Basically, coastal areas means those areas which are near to water, okay, near the lakes, near the seas, okay. Those areas, what happens is that sun is like shining in the day, okay. So in the daytime, the land that is there heats up faster, okay. The land heats faster than the water. Okay. So what happens that when this land heats faster, the air on the land becomes hot. The air that is on the land becomes hot and it rises up. We know that hot air rises up, right? So this hot air from the land rises up, okay? And then the cool air from the sea, this is cool air from the sea comes to take its place. Okay, cool air comes to take its place. This happens during the daytime. Now, in the nighttime, now both things have to cool down, right? The land also, the sea also. So the land becomes cool faster than the sea. Okay, the land cools down faster than the sea at night, so hot air rises from the sea. Okay, hot air now will rise from the sea. Okay, now hot air will rise from the sea and cool air from the land. This cool air from the land will come to take its place. Will come towards the sea to take its place. Okay, so this phenomena, this cycle is known as land breeze. This is second one. We call it a land breeze, and the first one. See here, land from cool air from land is going. Okay, when cool air from land is going, okay, it will be known as land breeze. From land is going. So land breeze. Okay. And the in the other one we have the hot air from the sea is going towards the land. Okay. Sorry, cool air from the sea is going towards the land. So this is known as sea breeze. This is known as sea breeze. Okay. Understood. Land breeze and sea breeze. Any doubt in this topic? Okay.
No, ma'am.
Okay. Emma, turn on your video. Yes. Then we have properties of clothes that we wear in summer and winter. Okay. Now you must have seen that people wear dark color clothes during summer. Sorry, light color clothes during summer and dark color clothes during winter. Okay. Why does that happen? Can anybody of you tell me? Unmute and tell. Why do we prefer to wear light clothes in summer and dark clothes in winter?
Because maybe like heat black color absorb like what do you call that, absorbs heat, meaning like when I wear a black color, when I wear black color t-shirts or whatever, the heat will become absorbed and I will feel more hotter. But when I wear light colored clothes like such as white and other colors, when they don't absorb like white, they don't absorb heat that much and they keep your body more cooler.
Yes, Ibrahim, that is right. Good, Ibrahim. This is one of the reasons why we wear light color clothes in summer because they do not trap heat, whereas dark colors such as black they trap heat. So our body will feel more hotter. Okay, this is one of the reasons. Another reason is that the light colors the light colors allow the air to pass through easily and keeps us cool. Okay, the light colors allow air to pass through the fabric and keep us cool, whereas the woolen clothes or the dark color clothes, the air doesn't pass through them very easily. Therefore, we feel hotter in them. Okay. In the winter, we use woolen clothes. Wool is a poor conductor of heat. Moreover, there is air trapped in between the wool fibers. This air prevents the flow of heat from our body to the cold surroundings. So we feel warm. Suppose you are given the choice in winter of using either one thick blanket or two thin blankets joined together. What would you choose and why? Remember that there would be a layer of air in between the blankets. It is therefore said that in winter one should be dressed in layers instead of single thick cloth.
Ma'am, I think double thick cloth would be better, ma'am, is because the two thin blankets they would trap some air inside, but because they're not stitched from all the sides, the air will come out, and then it'll just be like two pieces of cloth.
Mm-hmm. Because they are not stitched together. If the placement gets disoriented, then you'll feel cold. If like you just put one blanket on the other blanket, sometimes we sleep and we don't know the one blanket slips off. One blanket just slips off. That time we'll be just left with only one blanket, and it will feel colder because now it's just one thin layer.
But ma'am, when these people talk about winter, in winter it's not that cold.
Uh, it's not that cold means.
It is very cold here in MCC, ma'am.
In
Okay.
Mumbai, it is like kind of like summer.
You don't like summer.
No, no. In winter in Mumbai, there's almost no difference.
No difference. Okay. Mhm. Here we have like extreme cold. In Rajasthan, we have extreme cold in winters and extreme heat in summers. It's like both the things. Summers also excessive and winters also. Okay. So even I don't really like summer. I like winter more. Like that. Okay. Joshua, where are you from?
India,
India, yes. Which state? From which state in
Kerala.
India?
I'm from Kerala.
Kerala. Kerala. Okay. Okay, that's very nice. Okay. We have Abraham from Mumbai and Anna from, say loudly, Anna.
Chennai, ma'am.
Chennai, Chennai. Yes. Anna from Chennai and Emma is also
Bye.
Mumbai. Mumbai. Yes. Anna, Emma Abraham from Mumbai. Then Joshua from Kerala. Okay. Okay. Now, all right. But usually it is advisable that when we are like going out in winters, it's better to wear multiple layers of clothing, multiple layers of this woolen clothes. Okay, 2 or 3 layers to like so that it can absorb heat well and you can stay warmer. Fill in the blanks 10.2. The process of transfer of heat is called
Dissipation.
distribution.
No, no.
Propagation of heat.
Propagation.
Plastics and wool are dash of heat.
Propagators.
No.
Non-propagators.
Conductors or insulators.
Insulators.
Insulators. In solids, the heat is transferred mostly by
Metals.
say again.
Metals.
Metals. Metals, yes, but I think it's gonna be one of the convection, conduction, or radiation. Do you want to check it? 10.2. If it's metals or Conduction. It's conduction.
How does it fit in the sentence?
How does it?
The sentence. See, ma'am. This
Understood now?
follows
Yes, tell me.
nothing.
Conduction is the process when the heat gets transferred from one solid like to another or in a body of solid. The method that the heat takes is the conduction method. Now, smoke from the chimney is released out by the process of convection. Next, we have true or false. The heat always flows from a hotter object to a colder object. Is that true or false?
I'm not sure. I think it's true, ma'am.
It's true.
It's true.
Copper and iron are bad conductors of heat. True or false?
False, ma'am.
False. This is transfer of heat by convection.
False.
Yes. False. What is the process in which the process that it does not require any medium?
Radiation.
Radiation. Very good. Light colors reflect most of the heat that falls on them. True or false?
False, I think, ma'am.
Light colors reflect.
Yeah, it's a true. Because the light color reflects, the black color absorbs. That's why you feel hot.
Yes, light colors reflect and the dark colors absorb. This is correct. At night, cool air from the sea moves towards the land. Is that true or false?
False, because hot air from the sea moves towards the land. That's why
Yes.
it's called sea breeze.
Yes, because cool air from the land moves towards the sea. Okay, in the night time, that is land breeze, and in the daytime, the cool air from the sea moves towards the land. That is sea breeze. Okay, now mark tick against the most appropriate answer on the following. A wooden spoon is dipped in a cup of ice cream. Its other end
Becomes cold by the process of conduction.
becomes cold by the process of conduction. Okay, Anna,
I'm still thinking, ma'am.
you're still thinking. Okay, 1 second, I want to confirm this one. Yes, this was what I was thinking, that it does not become cold. Okay, because cold does not pass like the object becoming cold. The heat is an energy that like passes in an object, propagates, but cold doesn't really propagate like that.
You're right. Cold
Yes,
may not propagate.
yes,
But the problem is, when I have the spoon, that spoon has some amount of heat in it, right? Because you have your thermometer of your hand. The heat, you said that the heat from a spoon, the heat always flows from the hotter substance to the colder substance. So the heat from the spoon will flow through the ice cream. Thus the spoon's overall temperature decreases, and that's why the spoon becomes colder.
Yes, spoon becomes colder.
Remember, it's correct. The spoon becomes cold by the process of conduction.
Okay, that's why you mentioned that the spoon becomes colder by conduction. Okay, but I'll have to look this up a little more. It can be A and B. Okay, because you're like it was logical how like the spoon has some energy of its own. Okay, and how it gets colder by the process of conduction. Okay, but moreover, like conduction, convection, and radiation work more with heats. They are the processes of transfer of heat.
Yeah, ma'am. That's what I'm saying, ma'am. It is using heat only, ma'am. But, ma'am, your process is getting reversed. It's like heat from the cream is not coming to the spoon. The heat from the spoon is going to the ice cream. That's why the spoon will be able to cut through the ice cream easily sometimes. Like if I have an ice cream, I will normally use a spoon to cut, and it won't be it will be difficult to cut it through with like something else.
Mm-hmm. Okay, okay. So I'll consider A and D. Next we have combustion. We will do combustion tomorrow. Okay, we are going to do combustion tomorrow's class, and right now we are going to start with maths. Okay. Okay. Hi Nathaniel. Good morning.
Good morning, ma'am.
How are you now, Nathaniel?
Ma'am, I'm much better now.
You're much better. Okay,
Yes.
that's good. So once like you find time, you feel better, please watch the previous lectures, okay? From YouTube. I have shared the link in the group.
Yes, ma'am. I already watched them yesterday.
You already watched them yesterday. Okay. All
And
right.
ma'am,
Yes.
I was doing the homework and I found it hard to do question 3 and 6.
3 and 6. Okay. Okay, Nathaniel. I'll take a doubt class. Okay. I'll take a doubt class for y'all. Maybe like we can do it tomorrow or we can do Monday. The doubt class where I'll be taking your doubts together from whatever we've covered till now. Tell me tomorrow or Monday, the doubt class. When can we do it? Abraham, you're saying something?
I mean, I have some doubts of the seventh chapter that you have taught.
Okay. Seventh chapter, doubts. Let's do it. Let's do it tomorrow. Seventh chapter. Yes.
Tomorrow there will not be any class. Tomorrow's test, right? No test.
Okay. Okay. No test is there tomorrow. You have a math test of the fifth chapter tomorrow, the algebra chapter. So prepare for that. And tomorrow, like math test is there, right? So we'll just be having science. Monday, let's do your doubts. Okay?
Ma'am,
Yes, Anna.
I did not submit my science test because I was not able to do it because yesterday I was busy. A lot of people have come home, so I'll finish it today and submit it.
Okay, Anna, sounds good. You can finish it today and turn it in. Okay. Monday, I'm going to take your doubt. Till then, you'll be able to do one more exercise. Okay, that we will cover today.
Okay, ma'am.
Okay, so you can do that also, and I am going to take all your doubts all together on Monday. The next we have is the next topic that we have. We just covered time and work. We have now time and distance. Time and distance. Yeah. Also, why I'm saying is because I'm still yet to check some of your homework. I'm still yet to check some of your homework. So I want to like go through it first and find out what problems you all are facing. Okay, your doubts and the questions and all. So I'm going to check your homework and send it to you. So then like Monday we will do the dark class. What happened, Anna and Joshua?
No, ma'am, my sister is disturbing here.
Your sister is disturbing there.
And my brother is also here.
Okay, sibling problem. Okay, just tell them to disturb you at after 9. Okay. Okay, Abraham, Nathaniel, Imam, turn on your videos. Now we have time and distance. So time and distance, we have time. 2, 3 formulas are there that are usually used here is equals to distance upon speed. Distance divided by speed. And we have distance. If you have to find out distance, we'll take distance this side. We'll have time multiplied by speed. And when we have to find out speed, we have distance upon time. Time equals to distance upon speed. Distance equals to time multiplied by speed. And speed equals to distance divided by time. Okay, these are the three formulas that we use in time and distance. Okay, whenever we have to find out time, distance, or speed. Okay, now there are two more things that are there. Okay, there are two more things that I want to talk to you about. They are known as they are or like one thing that is there, relative speed. First, write down the three formulas and then we'll see what is relative speed. Once you're done writing, let me know.
Done, ma'am.
Done. Okay. So when I say the word relative speed, first let's see what's the meaning of relative speed. Okay. Relative speed shows the relation between two objects, okay, between the speed of two objects. Say one is moving and the another can also be moving or stationary. Okay, that is how fast one object is moving in relation to another. Okay, in relation to another. So, relative speed is the speed of one moving object. Speed of one moving object in relation to another. Another moving or stationary object. Moving or stationary object. Now, how do we what do we consider? Like we consider the direction of motion to find the speed. We consider the basis is the direction of motion. Direction of motion is the basis. On this basis, there is two things that we can do. On the basis of direction of motion, we have two things that we can do. Okay, what are those two things? If two objects are moving in the same direction, if two objects are moving in the same direction, this is my car 1 and car 2. Car 1 is moving here, car 2 is moving here. Okay, same direction. Okay, when two objects are moving in same direction, suppose my car is moving straight, another car is also moving straight. They are moving in the same direction. Okay, this is the first condition. Whereas the second condition is when my two cars are moving in opposite direction. That is car 1 and car 2. Car 1 is coming like this and car 2 is going like this way. Car 1 is coming like this, car 2 is coming like this. They are coming in opposite directions, okay, or they are moving in opposite directions, right? So this is the second condition. What do we do in both the conditions? If objects moving in the same direction, you subtract the slower speed from the faster speed. Here, we subtract the slower speed from the faster speed, but if they are coming in opposite direction, we add their speeds. Okay, we add their relative speed. If the cars are going in the same direction, then we subtract the slower speed from the uh, faster speed. But if they are in the opposite directions, then speed we will add. Suppose car A and car B. Okay, car 1 is A and B. So I will do in the same direction. I will do A minus B. Okay, when A speed is more than B. Okay, if B speed is more than A, then B minus A. Okay, and in car 1 and car 2 that are opposite direction, that are coming in the opposite direction, we will do A plus B. That is, we add their speeds. Remember, in like relative speed, if both objects are going in the same direction, we will take the object with the slower speed, subtract it from the object that has the faster speed. Okay, and in the like second case where objects are coming in opposite directions, we will add them together. Okay, this is the concept of relative speed. Tell me that you're able to understand or not.
Completely
Ma'am, I
understand.
understand.
Yes, ma'am.
Okay,
Just one question, ma'am. Why do we need to calculate the relative speed? Like, what is
why
this?
do we need to calculate the relative speed? See, Abraham, sometimes we have the question where we are to work with the speed of the two moving objects. Okay, now one object is there, we can calculate speed. When we have two objects, we have to calculate in reference to the other one how fast this one is moving, in relation to the other one how fast this one is moving. Okay, we have to calculate it like that. That time we need a relative speed. Okay, that time we need a relative speed, so that is why relative speed is calculated. Okay, now what we will do, what we will do, we will do a question. First, write this down. Tell me everyone has written. I'm going to clear it.
Almost done, ma'am.
Okay,
Same here.
okay. Yes.
Done, ma'am.
It will be A plus B if the car is moving like different directions like this, right, ma'am? Like one car is moving like this and one car is moving like this.
Yes.
Away
When
from
they're
a
moving
point.
now. Yes, when they are moving in opposite directions, we have A plus B. Okay, let's see a question.
Done, ma'am.
Okay, see, a train is moving with a speed of 60 km/h. Find per second speed of the train. Find speed per second. We have only one train, so you just have to calculate the speed. Okay, just have to calculate the speed. So we have in 1 hour, in 1 hour, train is moving how much? 60 km. Okay, that is equal to 6,000 meter, right? 6,000 meter. In 1 second, the train will move. 1 second.
100? 100 meters, ma'am?
No. The train will move 60,000 meter upon 3,600 seconds. Now we cancel it. 1 minute.
And why 3,600 seconds goes underneath?
Why 3,600?
Seconds goes underneath.
In 1 minute, there is 60 seconds. That is right. Then in 1 hour, how many seconds are going to be there? Okay. If in 1 minute, there are 60 seconds, in 1 hour, how many seconds are going to be there?
3,600.
Yes. So that is why. Yes, Anna, you can drink water. So that is how we have 3,600. Okay. Then cancel it. Cancel it. Yes.
So if we cover 2 meters in 1 second,
Answer. And 3 times 0. 50 by 3. 50 by 3. Okay. 50 by 3 is the answer. Okay. But if you want to, you can divide and convert it to decimal. Okay. Or like a mixed fraction. If you want to convert this, you will get 16.66. Okay. 16.66 meter per second. Meter per second. Okay. You can also divide and do it in mixed fraction. Okay, divide and do it in mixed fraction too. That's also fine. It's in mixed, it's gonna become 16 whole number 2.3 meter seconds. Okay, please write it down. Okay, done writing?
Yes, ma'am.
All
Yes,
of
ma'am.
you?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. See, take a look at this question. We have relative speed here. A and B. A and B are moving from their houses from their houses 40 kilometers apart towards each
Ma'am,
other. Yes, yes.
can you just show the last part, like the last question again? I have a doubt.
Okay.
Yeah, ma'am. So my question is this: 600 comes in the table of 36, right, ma'am?
600 is,
Coming in the table of 36.
yes, 600 is coming in the table of 36. I cancel with 2, Abraham. 600 will not directly come in the table of 36, I think.
No,
Yes.
ma'am, it comes. It's 36 20s are 600. And when you cancel it out by 36, you get it 36 to become 1. And then you get 60 to become 20. So it becomes 20 upon 1, which can be written as 20. So
You
shouldn't
are
the
saying,
answers be
okay,
20 meters per
Abraham,
second?
you are saying that 36 times 20 is, is 600.
Yes, ma'am.
No, Abraham, 36 times 20 is 720. Multiply and check, it is 720. 600 is not divisible with 36, okay? 600 is not divisible. I reduced it with 2 because 636 even numbers. So I reduced it with 2 and I got it in fraction, that is 50 divided by 3. Okay?
Okay, ma'am.
Towards each other with a speed of with a speed of 4 km/h and
Ma'am.
6. Yes, Anna.
Joshua.
Yes, Rashma.
It says A and B are moving from their houses 40 kilometers what toward each other.
40 kilometers apart. APART. Apart.
Thank you, ma'am.
Okay. After how much time and where will they meet each other? Okay. Now, first we have to find out the relative speed. Okay. First, we have to find out the relative speed. Tell me
Is it
that
10?
which direction is it? Yes, Abraham. Yes. Good. It is 10. Because this is a question where both are going in opposite direction. Opposite direction. Therefore, relative speed will be a plus b, that is 6 plus 4 equals 10. Now, using the relative speed, find out total time taken to cover 40 kilometer distance. But you have to use relative speed because I am talking about both A and B. Find out using the relative speed, find out the time taken to cover 40 kilometer distance. What's the formula for time?
Ma'am, is it speed
Ma'am,
into time?
Speed into time? No.
speed into time is equal to distance. No. Time upon speed is equal to distance.
We have the distance 40 kilometer. We just calculated relative speed 10. Okay, 10. Tell me the time formula. I'm asking. Time.
Time is equal to distance upon speed.
Yes. Distance.
So, ma'am, is the answer 4?
Yes. Distance upon speed. What do? Distance is 40 kilometer hour. 40 divided by speed is 10. The relative speed we are taking because we are talking about both the objects. So together speed 10. Cancel and time taken is 4. 4 kilometer. Oh, sorry, not kilometer hour. Time taken is 4. Okay. We have time is 4 hours. Okay. Now, after 4 hours, A will travel how much? Okay. After 4 hours,
Ma'am, is it 24? And
no, 4 hours, A will travel. Distance is equals to time into speed. Distance equals to time into speed. What is the speed of A? Speed of A is 4 kilometer hour. And time I have just calculated 4 hours. Multiply.
so, ma'am, am I correct? I said 30. I said 24.
16, Abraham. 16. Okay. We have speed into time. Speed into time. A ka speed is how much? 4. That is in the question. Time we just calculated how much? 4. So 16 kilometer is the distance. Okay. Now A and B will meet each other after 4 hours. Okay. After 4 hours. And 16 kilometer from A's house towards B's house. A and B will meet after 4 hours. 4 hours and 16 kilometer from A's house towards B's house. I'm gonna do a diagram for you.
Ma'am,
Yes.
what if I calculated the opposite way? I'm getting 24 km. Plus 6 fours are 24. But 24. Ma'am, so we could also do that oppositely, ma'am. We could add 40, right? We could subtract 16 by 40, right? We could calculate it anyway, right? Ma'am?
Abraham, I didn't understand your question. Your voice was breaking for me.
Could we calculate this anyway?
Can we calculate this anyway from B you want to calculate? You can do that, Abraham. Okay. If you want to do it like 6 times, okay, we're doing 6 times 4. Okay, yeah. So 24 you're gonna get. That is your from like B side. Okay. Did you all understand the question?
Yes, ma'am.
Yes,
Joshua?
Ma'am.
Yes or no?
Yes, ma'am.
Yes. Okay, good.
Yes, ma'am.
Okay, good. Good answer. Now, try out some questions for from the exercise 7.6. Try some questions from 7.6. Okay, this might be a little hard, but do whatever like you are able to understand because we are yet to try out some more examples. So, Monday I'll take doubt. Tomorrow math test is there. Science class will be there as usual. And Monday I'll take doubts. Tuesday I will take more of your examples from speed and time, distance and time, speed, all three. Okay. 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 Please submit your science tests by today. All of you, Abraham, Anna, Emma, do them today and submit me. So tomorrow you all have maths. Okay. Before math you need to submit. Okay. Then we'll meet for class tomorrow. Yes, Joshua, you have a doubt?
Ma'am, when is the maths test?
Tomorrow.
Okay, ma'am. Thank you.
Okay. Okay. See you all then. Bye. Have a good day.
ma'am, 1 second. Can I copy this?
Yes, yes. Copy it.
Bye, Joshua. Bye, Anna. Bye, Emma.
Bye, Abby.
Ma'am, I also need to copy it down. I copied it only halfway through.
Okay, Anna, Nathaniel, you can write it down. Emma, Joshua, if you've written, you can log out.
Bye, ma'am. Thank you.
Okay, bye.